So why is it called unijunction? Unijunction has only one p-n junction enter base 1 and base 2. Here n-type bar is there, where p-type emitter is an emitter, where n-type bar is there, p-type emitter is inserted in n-type bar. B2 and B1 are connected. B2 and B1 are connected. But here B1 and B2 are like P-type emitter works as a distributor for B1 and B2. Here what is inside uJT? Uh, think of it as N-type bar with few terminals at a time. Here P-type emitter becomes forward bias with N-type barrier, and B1 and B2 are the two side terminals of N-type. We can think of like a voltage gradient between V1 and V2 is the, let's say we call it VBB, and the peak voltage will be like formula Vp equals to N eta VBB plus VD. Um, and what happens in the unijunction diode, unijunction transistor? Here VBB equals to voltage between V2 and V1, like voltage gradient. Forward VD equals forward bias of interjunction. For interjunction is forward bias with the N bar. The peak voltage is called VP. With the formula for peak voltage is neta VB plus VD, where neta equals to standoff ratio, intrinsic standoff ratio. The most important uJT characteristic is it acts as negative resistance region, same as a tunnel diode. So uJT acts as an voltage distributor where if we give supply a positive voltage to P, it is forward biased with the voltage gradient of n bar. Let's say n bar B1 is connected to plus 10 volts, B2 is connected to 0 volts, like connection of battery. Then the voltage gradient is in forward bias with P, P positive voltage. A battery has, let's say, battery 10 volts minus volt, plus terminal B1 and minus terminal B2. So here you can see B2 and B1, plus terminal B1 and minus terminal B2. There should be a difference. If no difference, 0. At that time, it will not forward bias with P. So enter it is in forward bias. So this is the picture you can see, and the simplified circuit where B1 and B2 are connected. This is how the transistor is. So what is the difference between a p-type semiconductor and p-type emitter? P-type semiconductor and p-type emitter are same, but the based on the rows we named it as p-type emitter for this because it emits from current from P to N bar, where N bar B1 and B2 both sides distributing the current. That's why we call it p-type emitter. We call it N bar beats. For N bar, it is so long than the normal N bar. So we call it an N bar. That N bar acts as a channel. So here P-type semiconductor generic material, P-type emitter, P-type agent functioning as emitter, N-type semiconductor general material, N-type bar, long N-type agent connecting B1 and B2. What's the meaning? So, so one important thing is this N-type bar acts as a resistance from emitter to B2. It acts as RB2. For emitter to B1, it acts as RB1. If you look at the picture, it acts as two resistors, N-type bar. So current is distributed, not always equal. For example, B2 is 10 volts and 0 and B1 is connected to ground, like negative terminal. Then the difference between is 10 volts. That is the voltage gradient, which is in forward bias with the emitter. It is like you can see the P and N are forming a depletion region. They also have a depletion region, and a mobile carriers are recombining is happening. Mobile carriers are disappearing, and those are all happening parallelly for a unijunction transistor. Current is distributed from B1 and B2, but the distribution is not equal on both sides. That's the function. It acts as an oscillator. Here you can see resistance is RB2 and RB1. It acts as a resistor and bar. So when we apply pulse voltage at least, it injects force in the N bar. We injected horse doesn't receive in magically. Okay. So and also make sure the anti-bar doesn't works like it is one side to doped strongly, one side doped weakly, not like that. It is it distributes differently because the potential because of the voltage gradient. The key thing to remember is VB is equal to VB2 minus VB1, which we call it voltage gradient, voltage difference, where usually the condition is one value should be greater than the other value, like B2 should be greater than B1, or B1 should be greater than B2. Then only the voltage gap is replaced by voltage gradient replaced. So that's it. So the formulas are eta equals to RB1 by RB1 plus 2 BB1. Thank you. Thank you for the.